All right, so in this lesson, BC2 Part 1, I decided to make it 2 parts, one on segments, one on angles next time. So this time we're just going to look at segments and how to measure them and how the proper notation for that. We can open it up here. Now this is something we're already familiar with, that AB with a line above it means line AB, right? And so that's how you read it. That's how you draw it. AB with just a single arrow on top means ray AB. And you draw it with one endpoint going in either direction, but having an endpoint at endpoint at A going through B. And then AB with a single bar above it means segment AB. And that just means A and B are the endpoints. And this last one's new. AB without anything on top of it is referring to the length of that segment, but not the segment itself. Right? So this means that segment. AB means the length of it. So we're going to write length of segment AB. And because we were talking about a length, not a figure, we're going to say that this notation is always going to be equal to a number or an expression. Okay, so the letters without a bar on top refer to the length from point A to point B. And the bar over the letter means that you are referring to the segment itself. All right, so one method for measuring a segment is to just put a ruler up next to it, and every part of the ruler corresponds to some point on that segment. And so we just call that the ruler postulate. So every point on a line can be paired up with a real number on a number line, and the real number that corresponds to a point is called the coordinate of that point. Okay, so -2 corresponds to point A. So if we want to find the distance between these 2 points, we put a ruler up next to it. Anytime you find the distance between 2 numbers, you subtract. Like if I said, what's the distance between 7 and 10? You'd go 10 minus 7. So when we say, what's the distance between A and B? We go A minus B or B minus A. It doesn't matter because distance is positive and we're going to find the absolute value of it regardless. So we say the distance from A to B, we could say is 2, that's the coordinate for point B, minus -2, that's the coordinate for point A. That gives you a length of 4 units. Okay, so this page we're going to do a little practice. In my notes I have a we do problem and then I have a you do. So we'll do this one together and then I'm just going to let you do this one on your own. So in this case, it says find the length of segment PR. So that means we want to write PR equals. The length of segment PR is equal to the absolute value of one coordinate minus the other coordinate. So -5 is the coordinate for P, minus 4, which is the coordinate for R. So we got the absolute value of -9, which is 9 units. Okay, so just be aware on this problem, it says what is QT? That means the length of segment QT. Okay, so do that one on your own. And you can come back to it after the notes are done if you want, after you watch this video. Or pause it. Okay, in this one we say QS equals. It's just another way of asking the same question, what's the length of QS? And we can just look at the number line and we can count 1, 2, 3, 4, 5, 6, 7. Okay, so QS is 7 units. Number 2, a similar problem but without the number line. It says J has a coordinate of -2 and segment JK has a length of 4. What are the possible coordinates of point K? Well, it's probably easiest to look at this on a number line and say, all right, I know that J has a coordinate of -2, and the length of our segment is 4. So if I went 4 units to the right, and that was K, what would be the coordinate of that point? Well, you just add 4, and you're at +2. If we went 4 in the other direction, that's another possible location for K, and the coordinate of that point would be -6. Okay, so we could have -6 or +2. Okay, so you're going to do this one, and when you come to class, you'll have your notes open. I'll come around and check that you've done the you-do problems. All right, let's go on to the next page when we just talk about congruent segments. And congruent, you may have heard that one before. I mean, I think you should have. It really just means same shape and size. But when we're referring to segments, they're just a line or just a part of a line, so they just have a length. So line segments are congruent. That's our symbol for congruent, if they have the same length. So if AB and CD are equal lengths, then segment AB and segment CD are congruent. And we can't say that two segments are equal, but we can say that their lengths are equal. Kind of vice versa. We can't say the lengths are congruent, but we can say the segments are congruent. And anytime we use the same number of hash marks on a segment, that tells us that those segments are congruent. So if I want to say that or show that AB and DC are congruent, I just put a little hash mark on each one that tells me they're the same length. If BC and AD are a different length, I use a different number of hash marks. And now that tells me that BC and AD are congruent. Okay, the midpoint of a segment is a point that divides the segment into two congruent segments, two congruent parts. So if we wanted to draw a diagram for the midpoint of a segment, well, we'd have to have endpoints. And we'd have to have a point in the middle, and you can label that M, doesn't have to be. But just that doesn't say that M is the midpoint, right? I mean, really, there's always room for error. It's probably not the exact midpoint anyway, where I put it. But if I put in a hash mark, that diagram now says that M is the midpoint of the segment. Okay, a segment bisector just means that we're splitting a segment into two equal parts, right? It's the thing that's doing the splitting. So a segment bisector can be a point, it can be a line, or it can be a ray or another segment that intersects a segment at its midpoint. So you can see in the diagram that segment ST intersects segment QR at the midpoint of QR. That's what that diagram says. So if we're going to kind of put that into words, and you're going to have to be able to do this, I'm going to say describe a diagram using words. Segment ST is a segment bisector of segment QR. Okay, that's what that diagram says. All right, so we are going to do this first problem. You are going to do the next two problems. Okay, so you look at this problem, it says find the value of x, then find the length of segment EF. So you look at the diagram and you recognize that there's hash marks. That tells us that those two segments are equal in length. The lengths are represented with 3x and 4x minus 5. So we can say that 3x is equal to 4x minus 5 because those two segments are congruent. And now we just do a little algebra. Let's say we move 4x over. We're going to get a negative x, but that's okay. We get negative x equals negative 5. If you take the opposite of the left side, take the opposite of the right side, and you get x equals positive 5. Okay, so that was one answer we needed. The second answer we need is the length of EF, so just this part. Well, there's a couple ways to do it. You could plug 5 into this, or you could plug 5 into that, and they're congruent. So 3 times 5 is 15. Now, we should get the same thing if we substitute 5 into this expression. 4 times 5 minus 5. Okay. Okay, you're going to do this one on your own. A similar problem without the diagram. So you need to draw the diagram, label it, and then solve. And then this problem, you're going to describe this diagram using the correct terminology, similar to what we did on the other page. Okay. All right, and the last part of these notes is on the segment addition postulate. And it's a real common theme in geometry that the parts always add up to the whole. Okay, whether it's a segment or it's an angle, we can say that when we break a segment into parts, we know that the smaller parts are always going to add up to the whole. So in this case, if 3 points, A, B, and C, are collinear, that means on the same line, and B is between A and C, then the length AB plus the length BC is going to be equal to the length AC. This part plus that part is equal to the whole thing. Well, that whole theme of part plus part equals whole comes around quite a bit in geometry, so we're just going to write it down. Common types of equations. One is part plus part equals whole. It's not going to show up all the time, but you're going to see it a lot. And another one is, especially when we're dealing with bisectors, is one part is equal to another part. Okay, so real two common formats for equations that we're going to see. All right, so in this problem, it tells us that the entire length is 59. It gives us expressions for the parts, and we have to find the length of each part. Well, we know that the sum of the parts is equal to the whole. So 8x minus 14 plus 4x plus 1 is equal to 59, right? So you don't need to put parentheses around it, but the first part plus the second part is equal to the whole. Okay, so now we just need to do a little algebra, combine like terms. 12x minus 13 equals 59. Now when you do this, I'm okay with you not showing that you add 13 to both sides. Maybe you get criticized for that. But if you just show your steps so that your algebra has this kind of format where it always narrows down to a single answer like that, I'm okay with that. I can follow your work. All right, so we found x, but we're looking for the length of EF and FG. So we're going to substitute 6 in for x into both expressions. So EF equals 8 times 6 minus 14. So EF has a length of 34 units. And FG, 4 times 6 plus 1 gives us a length of 25 units. All right, in this last page, you're going to do these problems, 1 and 2, 2A, 2B. In this last part, it's just, again, I just wanted to re-emphasize the notation part. It's not really an example exactly. AB has a length of 3, BC has a length of 8. Therefore, that's what these 3 dots mean in a triangle. Therefore, AC has a length of 11. Okay, well, the way we're going to write it is length plus length equals length. Right? Length plus the other length is equal to the whole length. We're not going to write segment plus segment equals a new segment. That's not the correct. Remember, you can't say that segments are equal. So this is an incorrect format. All right, that's it. If you need to go back and rewind and finish those problems, do that. If you have any questions, let me know at the end of this video. All right, thanks.